First of all, I'm glad to be here and glad to see you all here. Today we are going to talk about cloud migrations, do and don'ts. This is our agenda. But before everything, who am I? My name is Teodor Frunza. I'm a software engineer at Levi 9. I have approximately 4 years of experience, mostly in cloud development. I'm a cloud technologies enthusiast. I love everything about cloud and about distributed system and event-based systems. And as I said, most of my experience is in cloud, in Azure and AWS. First of all, what is cloud migration? Cloud migration is the process of moving the on-premise data centers to one or multiple cloud providers. There are three main cloud services, cloud type models. It's software as a service, platform as a service, and infrastructure as a service. First of all, infrastructure as a service is basically very infrastructure-oriented, kind of self-explanatory. Basically, the cloud provider only gives you the hardware and the virtualization for it, and you have to handle anything else, for instance, operating systems, licensing, security, and the code, of course. In the platform as a service model, this is more development-oriented, and basically, here you have everything up to the code, like you have the operating system, you have the licenses, the runtime environment, everything. And you can focus on writing the services that you want. The software as a service, this is kind of, you only have the service and use it. Google Drive is one of these examples that can be here. Also, there are three types of clouds, public, private, and hybrid. The public and the private are kind of self-explanatory. However, the hybrid means that you have some resources in the cloud and some resources are still on-prem linked to the cloud. First of all, why should you migrate to cloud? Well, the most obvious reason, reduce infrastructure cost and increase business agility. When you have on-prem infrastructure, you have to pay for the hardware, for the maintenance, for changing any component that fails. So this means money, and also the maintenance includes paying the bills and so on. About the business agility, cloud offers resources on demand. So basically, you can adapt very easily to any changes that the business asks. Remove end-of-life concerns. Well, this is about, you know that time when you have a software and it releases a new version, but they put you to sign a new contract and get a new license. Well, in cloud, this doesn't happen that much often. Like, they increase their versions, they get out new software. However, mainly the prices remain the same. Sometimes they increase, but not that not that often. Also, of course, increase availability, scalability, and elasticity. These are the main features of the cloud, of course. The better managing of increased customer expectations, kind of, it's included in the business agility, as I said. Cloud offers resources on demand. Increased security, it's pretty good in the cloud. However, this must be taken with a grain of salt, and we will see this in the challenges section. Common challenges. The first and the most important one is the proper planning. The planning phase has three stages: migration readiness assessment phase, migration planning phase, and implementation phase. If we handle any phase inappropriately, this may result in a critical impact on the migration process. In the migration readiness assessment phase, this is more like a business-oriented phase. This is where you look at your current infrastructure, you look how you want to do stuff, what fits. You do a financial analysis, of course, and in the cloud, it won't be like 100% correct. However, we must be as accurate as we can. And also start researching the cloud model that we want to use. In the migration planning phase, this is more technical, and you have to choose the cloud type and the cloud model. In some cases, as I said, you might want to go to a hybrid cloud instead of only of a public or private, as you want. You start creating the architecture and research and refine the unknowns, so we don't have that many surprises when you start implementing. And of course, create the roadmap. Implementation phase is pretty straightforward. Try to follow the roadmap as close as possible. It won't be perfect, but try to stick to it as much as you can, and adapt to any changes and limitations that you will encounter during this phase. About the hybrid cloud, an example would be Netflix. If you are something like this and you have a lot of media files, you wouldn't want it to have it in the cloud, because basically that would increase a lot the costs, and you might want a hybrid cloud. Yeah, some challenges and consequences of improper implementation would be the excessive time consumption and the additional expenses, of course, because fixing something takes time and money. Also, you may end up with an inappropriate state of product, which means if you hit like limitation or something that you didn't expect from a service, then you might find yourself to do a patchwork, or you can research another service. However, if you are going to that patchwork, and because of maybe time constraints, you might get a product that it's not that secure, it doesn't have the appropriate architecture, maybe it has increased in the efficiency and of course security, as I said. Maybe it's not that good at scaling, and because we are talking about a distributed system, you can lose data. And because we're talking about cloud, it's a privacy breaching, this can happen and it's pretty bad, we'll see in the next slides. Another challenge are the mindset and metric shift. Work in the cloud, as I said, involves distributed and event-based system, which implies changing the way the data flows through your system. Asynchronous and parallel programming become key concept as you are starting to use them frequently. Moreover, we know that in traditional system we have some metrics, like response time, and so on, we have a lot of them. However, in the cloud system, we have two new metrics that are kind of getting more important. It's the fault tolerance and the data consistency. The fault tolerance is because when we are working in a distributed environment, you might lose messages without knowing. In a traditional system, you have an exception, you catch it, everything is fine, or you have some mechanism holding them. So, however, in the cloud, you have to implement some fault tolerance here, and you have to monitor it. Data consistency is about eventual consistency and strong consistency. When going, for instance, serverless, you can go with Cosmos DB or DynamoDB, and you will see that the prices differ from eventual consistency to strong consistency, but you have to be careful which one you use for your system. Scaling can be done much more easier, but requires great thought to be masterfully. You can scale in and scale out, of course. It's a feature that cloud provides. However, we must be careful when we scale out to not let it stay there unless we have the load. Because if, for instance, now it's a heavy load and suddenly it lowers, you'll want to scale it back to how many instances you had before. And logging and monitoring becomes essential, as in a distributed system, event-based. It's pretty hard to follow the data through your services, so we must log and monitor everything pretty closely. Of course, we're getting to the security concerns. As I said, cloud gives you security, but it's not 100% secure, and cloud providers can be breached. For the platform as a service model, cloud provides you with a pretty good out-of-the-box security. However, we still must implement the security practice at software level. In the infrastructure as a service, because you have more control, but you have to implement more stuff for yourself, basically the security is a little bit lower. Most cloud providers have security for DDoS and port scan. So if you want to do a pen test or anything, you have to announce them that you are going to do this in a specific time frame and from specific IPs. But again, this security, it's pretty standard, and we have to implement security at software level. These are some solutions for our security. They're one-to-one, so basically, firewall from Azure is the WAF from the AWS, and yeah, of course, it's a firewall. Maybe you want to have a virtual private connection or a virtual network, block some IPs, whitelist other IPs. For a platform as a service approach, we have the API gateway and the API management, where you should have an API that has a GVT token, that has an API key maybe, and throttling to protect from DDoS. The load balancer does kind of the same thing as the API gateway, but for an infrastructure as a service perspective, and of course the load balancing part. CloudWatch and Monitor are basically two tools that you can use to follow your data through the system, to apply some metrics, have some alarms in case of something bad happening. And the Guard, Duty, and Sentinel are basically some strong services, pretty pricey. However, they have some machine learning algorithms that help you identify and patch and gives you insights on the security issues you have on your services. Of course, when you talk about security, you also talk about privacy. When we are working on premise, we have the data in our ecosystem, which means that we have full control on who accesses it, from where, so we are fine. However, in a cloud environment, the data stays somewhere else, stays on a server, which is not in your ecosystem, it's in theirs. And because you had a lot in the late years, had some regulations, and a lot of them, which are pretty pricey, on these privacy concerns, GDPR related, privacy should be a priority and be handled with great care. If we don't do this, we can have money and reputation loss, and that it's not good because the fines are pretty big. So what to do to have our privacy up to date? Well, use the least privileged system in which you only give access to the only required permissions at a given time for a given user. Also, don't forget to encrypt, obfuscate, and secure your data persistence layer. Technical limitations, I think this is the most often challenge that you will occur while developing the system. Working infrastructure as a service involves kind of the self-imposed limits. So basically you choose, if you are having like a virtual machine, you choose how many cores, how much RAM it has, so basically this is up to you. However, when working a platform as a service, this system has pay-as-you-go and dedicated solutions, and each of them have different limitations. Some advices are that always research the various services that you are going to use. Don't stop for the first option, because there are a lot that do the same thing. However, they do it a little bit different, and we must know which one to use, or we will hit a wall at some point in the future. Always investigate pay-as-you-go and dedicated solutions. Of course, you have the both options. Each of them has different limits. However, if you go pay-as-you-go and you don't implement them properly, you might end with to be more expensive than the dedicated solution, even if the dedicated might be pricier from the start, like the option. Choose what's best for your business case. I think this is the best advice. Like, always look at your current architecture and see what you want to use in the cloud. Research limits and costs before entering the development stage. This will help you a lot. And as I said, the budget won't be perfect, but try to stay in it as close as you can. Some limits, this is a note, some limits can be increased. Some services have some limits, but if you message the provider, they can increase the limits. And some services might offer better metrics for specific programming language. Here we have a study case on the serverless function. In the first table, I've added only 3 limitations, kind of the most important. And we have the AWS Lambda and Azure functions. We can see we have max concurrent instances, default timeout, and max request size. Why is this important? Because if you have a system, for instance, where you have payloads bigger than 256 kilobytes for the AWS Lambda, for instance, you won't be able to pass the payloads to the Lambda itself. Or if you have over 1,000 instances, that won't be possible. And it will become a bottleneck, where basically you have to wait for the instances to finish their task and then grab some other. The second table, as a disclaimer, first of all, the data is not that accurate and might be a little bit outdated. However, the purpose here is to show you that there are differences between programming languages for the same service. So for instance, in Azure Functions, Java has a cold start of 7.7 seconds. So I wouldn't choose Java to work with the Azure Functions because of this time. So be careful always what you use for the services. As some final words and some advices, always research thoroughly and don't be afraid to experiment with different solutions. Choose the best that fits your business case, look closely to what you need, and try to figure out the best solution. If you are just starting with the cloud migration, I would recommend having a cloud architect, of course. Do some POCs, test services, do a proper financial analysis, follow the planning phase as closely as you can, and encrypt and secure your data so nothing bad happens. Questions? Yeah, go ahead.
So, the whole stack on Azure functions, is it based on the basic, the plan, the consumption?
Yeah, the cold start is for the pay-as-you-go, indeed. and it represents the starting time of the instance for the Lambda, the installation of all the libraries used, and so on.
Using premium, I think, if I remember correctly, like 20 we have cold start.
Yeah, and this is exactly what I said about the dedicated and pay-as-you-go solutions. If you go with pay-as-you-go here, you'll have lower prices, but you have the cold start. If you go on the on-premium, also dedicated solution, you will have a pricier start, but if you need that to remove that cold start, it might be better for the future than using the pay-as-you-go from the start. That's why I said, make a plan and research all the options. They might fit you better